So I got cut off in my previous video. So just to have a quick chat about example number 4 is that your units there should be 12 meters per second squared. Here when we're working with newtons, remember, a newton really is 1 kilogram times meters per second squared. So you want to be following along with those same units. So that is what our final answer will be for our acceleration. As I said, make sure you guys put your make sure you have a sentence for your answer, and make sure you watch on sig figs. So you guys are more than welcome to move on to the on your own, or if you've already done so and are looking for the next section of notes, that is what we are going to move on to. Okay, so now we're going to talk about something called inertia. So inertia is basically a property that states that when an object is at rest, it stays at rest, and when an object is in motion, it tends to stay in motion. So it resists changes in its state of motion. Okay, so when you're pushing, say, a stationary object, say for example like a car, this is really hard to push. Or even if you take a different object, even like say a box, that one's going to be difficult to start, but then after you get it moving, then it's a lot easier. So when you're moving, it's way difficult to stop that object because it wants to continue going in motion. So you have to put a lot of force and say tackle this person with a lot of force in order to get him down. Okay. So say if we were accelerating a car, you feel as though you're being pushed back when you're accelerating. Your body, or actually the inertia of your body, is resisting the increase in speed. So when the car comes to a sudden stop, like say if you were to hit the brakes, your body wants to move forward and continue that forward motion. So in a car, the headrest stops the head from being pushed back if there's a sudden start, like there was a rapid pause of acceleration, so you were to put the pedal to the metal and race off. And so your seatbelts help prevent your body from moving during a sudden stop or a sudden change in your direction. So that'd be say like a negative acceleration where maybe you're slamming on the brakes. So say if you had a cup of coffee in your car without a lid, first of all, not a smart choice, but I mean, maybe you didn't have one or maybe it fell off. But if you were to start accelerating and you were watching your cup of coffee, you would notice that the coffee would spill on you when you're moving forward, so it's getting pushed back. If you were to stop, that coffee would actually move forward because it's trying to continue moving forward with what you were doing before. So inertia tends to stay in the same state that it was. If it was at rest, it's going to want to stay at rest. And if you were in motion, it's going to want to stay in motion. We kind of we have this ongoing joke about inertia is that, you get home after school or after work and you sit on the couch and your body's at rest. And you're like, oh man, I've got homework to do, I've got cleaning to do, but my body's resisting doing all this work because I'm already at rest, so I don't want to change. So anyway, so next time maybe your parents ask you to do some chores, just say that your body's exhibiting the property of inertia and that you can't move. It's resisting. Okay, so inertia also depends on one other factor, which is mass. So there will be less inertia if there is less mass. So there's less resistance the lower your mass is. So there will be more inertia if you have more mass. So say for example here we have two examples here. We have one child on a swing versus an adult on the swing. It's going to be much easier to push a child on a swing compared to an adult. You guys know that just maybe from experience, but now we're putting this into reasoning. Why is it easier? And you say, well, it's because the adult weighs more. Well, it's also because it's the inertia of their body is resisting that change. Okay? So who came up with this concept of inertia? So the concept of inertia was developed by Galileo, And he had said inertia is the object's resistance to its change in start of motion or rest. So we want to know, how did he do it? So he basically did a thought experiment, which is a common thing to do with physicists. We will see this in our 4th unit. Okay, so by using a pair of inclined planes and a ball, assuming there was no friction, Galileo observed that a ball which rolled down one incline would roll up the other side at the same height at which it started. So his basic thought process was, if I start with this ball and I drop it from a height and let it roll all the way down, it's going to come all the way back up at that same place, at that same height. And he found that even if you had a bit of a different curve, maybe it was a bit of a flatter curve here, it still came up to the same height. So what happens is that obviously this initial height should be equal to the final height if you dropped it from a slant that eventually just flattened off. So since that would not be possible, Galileo thought that the ball would continue in motion at a constant speed in a straight line forever, trying to achieve that final, or that initial height. And this is how he came up with the idea of inertia. That is it for this very long lesson, so thank you so much for watching. If you guys have any questions, make sure to message me on Remind101, or you can shoot me an email. Thank you.